Alright, good afternoon, Algebra 2 Trig Honors students. Today we'll start out with sequences and series. And this one is Chapter 8 from Algebra 2, the Big Idea textbook. So the first type of problem, given two terms of the arithmetic sequence, and find the common difference. And the first five terms, the 52nd term, and the explicit formula. So for arithmetic sequence, that means, let's say we do have a pattern. So let's say we do have 1, 2, 3, 4, so on and so forth. So in order to go from one term to the next term, you always have 1. Okay, so 1, then that would be the common difference. Okay, so this one, it goes all the way on to infinity. So what we need to find out, so we do have one of the formula. It's called the arithmetic sequence formula. So you started off with a sub n, so that equals a sub 1 plus n minus 1 times the common difference. So what I mean by a sub n is the number of the n term. So number in the n term. And then a sub 1, that means it's the first number of the sequence. So a sub 1 is always the first number. And then n, it's the number of terms that you have. And d, it's always called the common difference. So the common difference. Okay, so it's a tiny space right here. Let me just rewrite it on the other slide here. Give me 1 sec. File. Okay, right here. So a sub n. So that equals a sub 1 plus the quantity of n minus 1 times the common difference. So a sub n is the number in the n term. And then a sub 1 is the first number of the sequence. And then n, that just shows that the n term. And then d, that means the common difference. And this one is called the arithmetic sequence formula. Okay, so now let's use this one to find out things that it's missing for the first problem. Okay, so going back to that slide. So what we got here, a sub 15, it's 314. And a sub 40, it's 814. Now, for those you might be wondering, a sub 1, it's not given. It's not necessarily to start it with a sub 1. We can always use that formula to start it with the lowest term, the number of the lowest term. So the number of the higher term is 814, so a sub n. So let's say that it's 814. And then a sub 1 is 314. And then for the value of n, so you might be wondering how many terms are there from 15 to the 40 terms. So the total number of terms, then that would be considered 25. So you might be wondering 25, but it's supposed to be 26. Because you count the initial term, 15, and then the final term. So 26 minus 1, then that would be 25. So first thing that we can find out is the common difference by using that formula. So in order to solve for d, so subtract 314 on both sides, so we do have 500. So that equals 25d. So solve for d, so 500 divided by 25, then you'll get 20. So the common difference is 20. So we found the common difference already. So now find the first 5 terms. Okay, so in order to find the first 5 terms, okay, so let me just put it to the new slide here. So for A15, A40, so for A15, we do have 314. And then A40, we do have 814. Common difference that we found, which is what, 25? No, actually 20, excuse me. So common difference is 20. So now for the rest of this, we want to find out the first 5 terms. So that means we need to find out a sub 1. So using that a sub 15, that's the higher term this time. A sub 1, we don't know what that is. And then n, obviously that would be what? 15 terms. Minus 1. And then put in the common difference, the one that we found earlier. And then we solve for a sub 1. So we got 3, 14. A sub 1, we don't know. So 14 times 20. Then that would be 280. So 314 minus 280. So for a sub 1, we do have 34. Okay, so 34, then that would be a sub 1. So now you want to find out the first 5 terms. So a sub 1, so 34. A sub 2, so just keep adding 20. So 54. A sub 3, then that would be 74. A sub 4, then that would be 94. And then a sub 5, then that would be 114. Okay, so now let's see what else that we need to find out for this one. Find the first 5 terms after the common difference, the first 5 terms, and then the 52nd term, and also the explicit formula. So the 52nd term. So using that, the same formula, we can find out the 52nd term. So a sub 52. So a sub 1, we found it already, which is 34. And then n minus 1, so for the value of n, which is 52, minus 1 times the common difference. Common difference, which is 20. So basically just evaluate. So 34 plus 51 times 20. So 34 plus 1020. So it's 1054. Then that'd be a sub 52. So a lot of things that you need to find out here. A sub 1, the first 5 terms, the common difference, and then a sub 54. And then after we find out a sub 52, so we need to find out the general formula. So the general formula, then that'll be considered a sub n, the explicit formula. So a sub 1, which is what? 34. And then plus n minus 1 times 20. And this one here, we can simplify it a little bit. So a sub n. So 34. Okay, let me just get some space here real quick. Okay, so for the explicit formula, so 34, which is a sub 1 plus n minus 1 times the common difference, so times 20. So 34 plus 20n minus 20. So 34 minus 20, then that'll be 14. So for a sub n is 14 plus 20n. So we found a common difference, which is 20. And also we found that a sub 1, a sub 52, the first 5 terms, and then the explicit formula. Okay, so going back to the page. So you can always check the word down the bottom of the page. So number 2. Okay, so here's the 1. Okay, so now let's try another problem, which is similar to this. So for the other one, we do have a sub 12, negative 62, a sub 36, negative 158. Okay, so again, we need to find out the common difference first. So for the higher term, we can set that as a sub n, so negative 158. So that equals a sub 1, so negative 62, plus n minus 1, so for the value of n. So you want to count the initial term, a sub 12, all the way to a sub 36. So the total number of term, then that would be considered 24 plus 1, then that would be 25. 25 minus 1 times the common difference. So add 62 both sides. So we do have 96, negative 96. So that equals 24 times the common difference. And then solve for d. So d is a negative number then. Then that'd be negative 4. So after we find out the common difference, so we can find out a sub 1. Okay, so again, let me use the new slide here. So a sub 12 is negative 62. And the common difference that we found, which is negative 4. A sub 36 is negative 158. And common difference is negative 4. So using that, the same formula, the same structure, a sub n equals a sub 1 plus the quantity of n minus 1 times the common difference. So using that formula, so we can find out a sub 1, so using the lower term for a sub n, negative 62. Okay, making sure that's the right number here. Yeah, it is. So a sub 1, that's what we need to find out. So n, so 12 minus 1 times the common difference, negative 4. So a sub 1, so plus 11 times negative 4, which is negative 44. Add 44 both sides, so a sub 1, then that'll be considered negative 18. Okay, so common difference, a sub 1. And now we want to find out the first 5 terms, so a sub 1 is negative 18. A sub 2, so just simply add negative 4, so negative 22. A sub 3, negative 26. A sub 4, negative 30. And then a sub 5, negative 34. And then you want to find out the 52nd term. So using that a sub 1, negative 18, plus 52, because n equals what, 52, minus 1 times the common difference, which is negative 4. So negative 18 plus 51 times negative 4, which is negative 204. And then combine it with negative 18. So then that'll be considered negative 222. And then the last thing you want to do, find explicit formula for that a sub n. So a sub 1 is negative 18, so start out with the lowest term. And then plus the quantity of n minus 1 times the common difference, negative 4. Distribute, so negative 18 plus negative 4n plus 4. So eventually it's negative 4n, negative 18 plus 4, then that would be considered negative 14. Alright? So we found the explicit formula, we found the first 5 term, the common difference, a sub 1, a sub 52nd term. Okay, so let's check that. So this one's number 4. Okay, it's all that. So the other one is quite similar. So number 6, so that's the one you guys can figure out what that is. So the next one I would like to talk about is the geometric sequence. So for those you might be wondering, what's the difference of the arithmetic sequence and geometric sequence? So for geometric sequence, so we do have a pattern like this. So it's like 1, 2, 4, 8, 16. So instead of adding the number from one term to the next number, so we want to multiply. So in order to go from the first term to the next term, we multiply by 2. Multiply by 2, multiply by 2. So for the 2 right here, it's called a common ratio. So R, it's called a common ratio. Again, this one is just a random example. So for the formula that we have for the geometric sequence, so that one, it's always written as a sub n Okay, so this one's a geometric sequence formula. So a sub n, so that equals a sub 1 times the common ratio to the power of n minus 1. So a sub n, that means the number of the n term. A sub 1, that means the first number of the sequence. R is called the common ratio. Again, n is just the number of n term. Okay, so now going to the problem here. So we do have a sub 4, it's negative 27. A sub 3, it's negative 9. And we need to find out a sub 9. So before you do that, you want to find the common ratio first. And then you want to find out the explicit formula. And then finally, so we want to come up with that a sub 9. So using that to structure the formula, we do have a sub n equals a sub 1 times the common ratio to the power of n minus 1. Again, there's no need to start it with the lowest number. There's no need to start it with a sub 1. We can start it with the lowest term. So a sub 3 would be the lowest term. So negative 9. Common ratio, we don't know what that is. And then n, so from 3 to 4, so that would be considered 3, 4, so 2 terms. N equals 2, so 2 minus 1. And then a sub n, so we're using the higher number term, so then that would be negative 27. So solve for r, you can see that's pretty obvious, which is what? 3. Common ratio. Or basically this one you can just divide it, negative 27 divided by negative 9, instead of using the formula. So once we find out the common ratio, another thing you want to do, so you want to find the explicit formula. So a sub n for this, it's a sub 1. Okay, so we don't know what a sub 1 is. So that means we need to use that formula again. Find out a sub 1. Common ratio is 3. So we're using that a sub 3 as the lower term. Okay, so we're using that a sub 3 as a sub n. So negative 9 equals a sub 1 times the common ratio, 3 to the power of n minus 1, so 3 minus 1, because n in this case is what? 3. So once again, right here, we're using that a sub n as a sub 3. So a sub 1, so that equals 3 to the power of 2. So negative 9 divided by 9, then that means a sub 1, which is considered 1. So we found a sub 1, so we can rewrite the formula. A sub n, so that equals 1 times the common ratio, 3 to the power of n minus 1. And for those who might be wondering, can I simplify it a little bit? Yes, certainly you can do that. So this one, it's considered like 1 times 3 to the power of n divided by 3. Because n minus 1, that means it's just like 3 to the power of n divided by 3 to the first power. So another way you can rewrite it, it's considered 1/3 times 3 to the power of n. And for those who might be wondering, wait a minute, is that the exponential function? It is. So besides being this geometric sequence, this one is considered the exponential function. It's considered the exponential decay function because the number is getting smaller and smaller from from 1 and then negative 3. And then so on and so forth. Okay, so now let's try another one. So the other one, we do have a sub 1 is 1, a sub 6 is negative 32. So you want to find out the common ratio, explicit formula, and then a sub 11. Okay, so this one, using that formula again. So a sub 1 is given, a sub 6 is given. So started off with a sub 6, negative 32. So a sub 1 is 1. Common ratio, we don't know what that is. n minus 1, so 6 minus 1, which is 5. So r to the power of 5. So negative 32. So in order to solve for r, so we do know that it's to the 5th power. So in order to get rid of the 5, so we take the 5th root on both sides. So 5th root of negative 32, then that'll be negative 2. So the common ratio, which is negative 2. And then what else do we need to find out? Explicit formula. So a sub 1, we got it already, which is 1 times the common ratio, negative 2 to the power of n minus 1. So this one can be written as, without the negative exponent, so this one can be written as negative 2 to the power of n over negative 2. Another way you can do that is what? Negative 1/2 times negative 2 to the power of n. And don't forget, we need to find out the, a sub 9. For the previous one, we didn't find out a sub 9. So a sub 9, let's do it right here. So a sub 9, so for the explicit formula, we got 1/3, 3 to the power of 9. So that's going to be a big number. So 3 to the 3rd power, then that'll be considered 81. And then, so 3 to the power of 9. So it's 3 to the power of 3, 3 to the power of 3, times 3 to the power of 3. So 81 to the power of 3. So it's going to be a huge number. So that one, you can do that on the calculator and find out exactly what that is. Okay. So 3 to the power of 9. So let's see what that is. Okay, 81 times 81 times 81. So it's 5,300, it's 531,441 divided by 3. So it's 177,147. So it's a huge number here. Okay, so you're just plugging that to find out a sub 9. Okay, so that one is considered exponential. Wait, it's actually getting smaller? Okay, hang on a second here. Okay, so the common ratio we found, which is 3. Okay, let me check one thing here real quick. Number 8. Okay, so the common ratio is 3 for number 8. That's what we found. A sub 1, I probably did it wrong for a sub 1. Let's see what I got here. Okay, again, back to number A here. So for a sub 1, I found it. It's actually... Oh, you know what? A sub 1 is supposed to be negative 1. Sorry about that. Okay, so let's just work this out again. So back to number 8. So let me open up the new slide here. Apologize for that. So for number 8, a sub 1 is supposed to be negative 1. We found it. And let's see what else. A sub 4, it's negative 27. But let's use a sub 3. A sub 3 is negative 9. And we do know that the common ratio is 3. We found it already. So now we want to find out the explicit formula using that formula. So we do have a sub n. So a sub 1, negative 1 times common ratio, 3 to the power of n minus 1. Again, this one can be written as negative 1 times 3 to the power of n over 3. So in other words, it's what? Negative 1/3 times 3 to the power of n. Okay, so for a sub n. And now you want to find out a sub 9. So it's negative 1/3 times 3 to the power of 9. Yeah, so that makes sense here. Okay, going back, checking the work. So number 8. Yeah, explicit formula, it's negative 3 to the power of n minus 1. Well, that's just another way to rewrite it. That one is just consider negative 1 over 3 times 3 to the power of n. So eventually you'll get negative 6,561. Okay? So for number 8, negative 6,561. And then going back to number 10. Okay, so we found the common ratios. And now we just want to find the explicit formula. We got that already. Okay, and then you want to find out a sub 11. So negative 1/2. And then negative 2 to the power of 11. Okay, so again, checking the word, making sure that everything's right for the common ratios, all that. Yeah, common ratios, negative 2. Explicit formula, negative 2 quantity to the power of n minus 1. Well, which is the same as the structure that I put in for this. Because you want to simplify it a little bit more. So eventually, a sub 11. And that's going to be the result right there. Which is 1,024. So basically this one can reduce down by 1 degree. So it's just taking that negative 2 to the power of 10. 1,024. Okay, so now number 12, that one's quite similar. You guys can figure out what that is. Okay, so now the next set of problem. So given two terms of the geometric sequence, find the term name in the problem and the explicit formula. So basically this one, we do know that it's a geometric sequence, so we're using that formula again. So A1 times the common ratio to the power of n minus 1. So we need to find out the value of n and then the explicit formula. So started off with, well, another thing that's missing here is the common ratio. So perhaps let's find out the common ratio first. Okay, so for the value of n, actually that one, find the term name in the problem. Okay, so that means we need to find out a sub 9, not the value of n. So find the common ratio. So again, that's missing. So start out with the higher term and then the lower term. This one, instead of using the formula, we can simply divide it. So negative a over 4 divided by a over 3. So negative 2 over 125 divided by negative 2 and 25. So negative 2 over 25, that means you multiply by the reciprocal. Multiply by negative 25 over 2. So cross cancel. So 25 goes into 125 5 times. So eventually it's what, 1/5? So for the common ratio, it's 1/5. And then find out that a sub 9. So a sub 9, so we can start it off with the lower term, which is a sub 3. So negative 2 over 25 times the common ratio. Now, got to be careful with the value of n that you counted here. So instead of finding a sub 1, so you started off with a sub 3. So from 3 to 9, so how many terms are there? Then totally that would be what? 7 terms. So 7 minus 1. You might be saying that's 6 term, but the thing is that according to the initial term, you want to count that as well. So 7 minus 1. So negative 2 over 25 times 1 over 5 to the power of 6. So this one is going to be a huge number again. So eventually it's going to be negative 2 over So 25 times 5 to the 6th power. Okay, let me just do that here. So 5 to the power of 6. So that's 15,625 times 25. Oops. Okay, let me just do that again. So 15625 times 25. That's going to be a huge number. So 390,625. So this one, the denominator is actually pretty big. But let me check the result here real quick. Okay, so for number 14, so try to use a calculator for those kind of big, huge number, okay? Yeah, it is. So a sub 9, negative 2 over 390,625. And then find explicit formula. So using that, the same formula here. So a sub n, common, well, a sub 1, which is, well, we don't know. We still need to find out what a sub 1 is. So the way to do it, so this one basically you can just keep dividing 1/5 because you're going backward. So divided by 1/5. Okay, so we do know that a sub 3, it's negative 2 over 25. So divided by 1/5, how many times? Twice, right? So divided by 1 over 25, or instead just multiply by what? The reciprocal. So for a sub 1, it's actually negative 2. So a sub 1 is negative 2 times the common ratio. Common ratio, which is 1/5 to the power of n minus 1. Yeah, basically this one you can just leave it like that if you want to. If you want to simplify it a little bit more, you can do that as well. So it's a fractions with the negative exponent. So that one is like 5, 1/5 to the power of n times negative 10. Or we can just simply leave it like that. So 14. Yeah, so basically just leave it like that. Okay, so now let's see what else that we have for this one. So we got the explicit formula, and we found that a sub 9, it's a very small number, negative 2 over 390,625. That's a little comma right here. Okay, so now let's keep going. So the next one is quite similar. So just find out that the common ratio first, simply divide it. And once you get a common ratio, you can use that the lower term to find out a sub 11. But somehow you still need to find out a sub 1. Okay, so let's do one more. So number 16. So a sub 3, it's 8. A sub 4 is negative 4. So this one, obviously, it's declining. Okay, let's do it right here. So number 16. So a sub 3 is 8. And then a sub 4, it's negative 4. And let's see what you want to find out. A sub 11. Oops. So first thing that I want to do, find a common ratio. Simply divide it. Higher term divided by the lower term. So negative 4 over 8, which is what? Negative 1/2. And then once you get the common ratio, so you want to find out a sub 11. So using that, the lower term, doesn't matter, you can use the lower term or the higher term as a sub 1. So let's use 8. And then times the common ratio, negative 1/2. So from the third term to the 11th term, so how many terms are there? Then that will be considered 9 terms. Because you want to count the initial term as well. So 9 minus 1. So 8 times negative 1/2 to the power of 8. Okay, so what we got here, negative 1/2. Can't put it this way. Want to do it manually. Using the properties of exponent. So product to sum, or we can separate it out into into a product here. So negative 1/2 to the power of 4. So that one would be considered 1 over 16. Another 1 over 16 times 8, cross cancel. So it's going to be 1 over 32 for a sub 11. Well, because this sequence is alternating, because the common ratio is negative 1/2. So sometimes bigger, sometimes smaller. So 1 over 32. Let's check that for number 16. Yep. And then find explicit formula. Simply plug in a number back. So a sub n. So that equals a sub 1. So again, in order to get a sub 1, so basically you can just divide it. Okay, so a sub 3. So divided by negative 1/2. So in other words, multiply by negative 2. So you got a sub 2, which is what? Negative 16. And then divided by negative 1/2. Multiply by negative 2. So a sub 1, which is what? 32. So a sub 1, 32 times common ratio, r, which is negative 1/2 to the power of n minus 1. So we can do it that way. Okay, so checking the work. Okay, so for number 16, yeah, that's what we found. Alright, so thank you for watching the video today. So I'll see you guys next time for the other part of the sequences in series.